Here's another interesting question. We have a steel rod whose area of cross section is given and its Young's modulus is given. Now what happens is that a load of 2.16 kg is suspended from the middle point of the wire. So we need to find out the vertical depression in the wire. Let us see this question. The wire was initially like this and had no tension. Now the wire gets vertically displaced by some amount due to this 2.16 kg mass. This vertical depression will be very small. Let this angle be theta. This angle will also be theta by symmetry. We need to find out the tensions in the wire so that we can find out the stress and therefore the strain. Let this be equal to T. On this side also this will be equal to T. This angle comes out to be equal to theta again. Even this is theta. The horizontal component of these two T cancel and the vertical component of these two forces add up to give 2T sin theta, and that is balanced by the weight of this 2.16 kg mass, that is equal to 2.16 into g. Now this theta will be very small, therefore sin theta can be written to be theta, therefore T into theta becomes equal to 2.16 into g upon 2. We remember this result. Now we also know that Young's modulus, we have two equations and two variables. We have two variables now, so we need one more equation to solve this question. So the other equation will come out from the formula of Young's modulus, that is equal to stress upon strain. Y is equal to stress upon strain. We already know the stress to be equal to T upon the area of cross section, that is given to be 4 into 10 raised to minus 6 meter square. We need to write down the strain here. Let us find out the strain value. The initial length of the wire was equal to L. The strain will be always equal to, let us write this equation in one corner, T theta is equal to 2.16 g upon 2. Now strain is always equal to change in configuration upon original configuration. So change in configuration can be written as final length minus initial length. So that is equal to, this is L by 2, therefore this is L by 2 cos theta. Similarly this is equal to L by 2 cos theta, therefore we add up to give L by cos theta. So the final length is L by cos theta, the initial length was L and the original length was L, therefore this becomes sec theta minus 1. This can be written as, let us multiply numerator and denominator by sec theta plus 1 upon sec theta plus 1. Now since theta is very small, sec theta can be taken to be equal to 1, therefore the denominator becomes 2 and the numerator becomes sec square theta minus 1, that is equal to tan square theta. Therefore we get the strain to be equal to tan square theta upon 2. Now the strain comes out to be equal to tan square theta upon 2. Now again we know that theta is small, so for small theta, theta is equal to tan theta is equal to sin theta. Therefore tan theta, now we do not need this actually, we need to find out this x. So tan theta can be written as x upon L by 2, x upon L by 2. Therefore we substitute this here to get the strain to be equal to 4x square upon L square into 2, that is equal to 2x square upon L square. We substitute this value over here to get 2x square upon L square. The length is 1 meter, so we need not write anything else over here. The value of Young's modulus is given to be 2 into 10 raised by 11. So 2 into 10 raised by 11 into 4 into 10 raised by minus 6 into 2 into x square is equal to the value of T. We substitute this value of T over here to get 2 into 10 raised to the bar. Let us solve it a bit over here itself. T is equal to 16 into 10 raised to the power 5. Therefore, over here 16 into 10 raised to the power 5 into theta is equal to 2.16 g upon 2. There is also a term of x square over here. So we multiply this by x square. Now theta in a diagram, theta can be written to be equal to tan theta. Since theta is very small, this can also be written to be equal to sin theta, but we will use tan theta over here because we need x. Therefore, theta is equal to x upon L by 2, that is 2x upon L. L is equal to 1 meter, therefore theta can be written to be equal to 2x. We substitute theta by 2x over here to get 32 into 10 raised to the power 5 into x cube is equal to 2.16 g upon 2. Therefore, x cube is equal to 2.16 into g upon 64 into 10 raised to the power 5. This cancels here to give 10 raised to the power 4. This is equal to 216 upon 64 into 10 raised to the power 6. This is equal to 6 upon 4 into 10 raised to the power 2 meters. So the final answer comes out to be equal to 1.5 centimeters. So the final answer for the vertical displacement of the middle point of the rod comes out to be equal to 1.5 centimeters.